Okay, so parallel. Two lines that never meet, that are side by side. Okay, think what in real life can you think of that's parallel? Yeah, that's like the most common examples are railroad tracks are parallel, right? A ladder, yes. Like the pieces on a xylophone. Oh yeah, there you go. So there's lots of parallel things in life. So what do you know about perpendicular? The word perpendicular. Yeah? Okay, form a 90, I heard they cross. Yes, they do cross. What's a common example when we think of perpendicular? Intersection. Intersection is a common example. Yep. What else in life is perpendicular? The wall and the ground, we hope. We hope. Otherwise, we have some issues with the construction, right? We want our walls and our floor to be perpendicular to each other. So we're going to look at the slopes of parallel lines and the slopes of perpendicular lines today. That's what we're going to look at. So we're going to look at their slopes and say, okay, what's the relationship between their slopes? When they're parallel, what's the relationship between their slopes? When they're perpendicular, is there a relationship? We're going to skip the transformation stuff here. Whee. Don't really like this warm up. Okay, so on the grid, there's a line segment AB. After the following transformation, a translation 4 units right and 1 down. Let's make CD. Okay, so let's take AB, let's start with A and move it 4 right and 1 down. You can do that, right? Can I make it larger? Zoom. So let's go 4 to the right, 1 down. 1, 2, 3, 4, 1. So you should land at the point 1, 0. Good? So C, I'll call that C. And then B, we're going to move 4 right, 1 down. So 7 and -3. Yeah. So draw that line. There we are. I'll make it nice and thick. Oh, that's too big. Okay. Little big. Okay, so there's that line segment, CD. All right. Let's do one more. Let's do EF. So let's now translate it 3 left and 6 up. So we're still starting at A. Now let's go 3 left and 6 up. Starting at A. So 3 to the left, 6 up. 1, 2, 3, 4, 5, 6. Right, way up there. And then starting at B, 3 to the left, 6 up. Should be 0, 4. And that is EF. Make it blue. Okay, so what's the slope of each one of these lines? So first, let's do the slope of AB. Can we just use rise over run? Are you okay with that? Okay, so A. I'm starting at A, I'm moving towards B. Rise is how much? We go up or down? Down, how much? Down 3 and right 6. So that gives me -3 over 6 or -1 over 2. Okay, let's do CD now. Slope of CD. So down, how many? 3, right? 6. Is that a coincidence? No. So we transformed all the points. So -1/2. What would be the slope of EF then? negative 3 over 6 or negative 1/2. So parallel lines are going to have the same slope. Okay? Parallel lines have the same slope. The slopes are equal, which makes sense. They need to have the same rate of change for them to never touch. If the slopes are different, then you have different rates of change, then they're going to cross and meet at some point. So the only way that they're going to never meet is if they're changing at the same rate. The y's and the x's are both changing at the same rate, then they'll never meet. Okay? Next page. Okay, so they want us to do some rotating. I don't like this. We'll give it a shot. On the grid, plot the point 5, 2. Okay, so we can do that. X is 5, y is 2. Right there. That will be point A. And join it with the origin. So origin is where? The center 0, 0. So I'm going to join that. Okay, we want to make a 90-degree angle and rotate this line 90 degrees clockwise. Okay, clockwise about the origin. So what would be the point?
A or B?
The new A. If we rotate it, yeah. 2 and negative 5. Would you all agree with that? So let's look at that. If I draw 2 and negative 5 and draw a line, let's make it red. Okay, does that look like a 90-degree angle? Yeah. So that's the point. So this was 5 and 2. And this is negative 2 and 5. Okay, and so that makes a 90-degree angle. That would make a 90-degree angle. Okay, we're going to find the slopes of each one of these. So we're going to find the slope. We would normally call the origin what letter? Yeah, it would be 2, negative 5, thanks. That's better. X is positive, y is negative. 2, negative 5. Sorry about that. Okay, so this is O. So we want to find the slope of OA and OB. Okay. Should we try with the slope formula? Or do you want to use rise over run? Okay, let's try with the slope formula because it's good practice. That's a point 0, 0. So OA, if we're dealing with the point, we're going to go y2 minus y1 over x2 minus x1. The change in y's. So which would be your first point? Which one do you want to do x1, y1? A or O? You want A? Sure. And O to be your second. So x1, y1, x2, y2. Doesn't matter. You could have made the other way around. So let's subtract. What do we get? y2 is 0 minus 2. Right? So we're going y2 minus y1 divided by x2 minus x1. So it'll be 0 minus 5. Which gives me negative 2 divided by negative 5, or 2 over 5. Two negatives make a positive. Okay, slope of OB. So now we have the points. Oops. B is, this is a B. 2 and negative 5. And O is still 0, 0. So what would it be? What minus what? 0 minus negative 5. So y2 minus y1 divided by 0 minus 2. Okay. What happens when you subtract a negative? Plus. So 5 over negative 2. Or negative 5 over 2. What do you notice about those two slopes? The reciprocals, one more thing. One's a negative, one's a positive. So they're the opposite signs and they're reciprocals of each other. And that's going to be the case for all perpendicular lines. Always. Okay, we're going to skip that little part. So when we call that negative reciprocals, perpendicular lines have slopes that are negative reciprocals. So what that means is opposite sign and flipped. Okay, opposite sign and flipped. Negative reciprocals. They also can be described another way. Because they're the opposite sign and flipped, if I have, say, a slope of 1/2, what would be the perpendicular slope? So if we know that one slope is a half, what would be its perpendicular? It's the negative reciprocal. So opposite sign, what's the sign right now? Positive. So it's now going to be a negative. And what do we do with our fraction? Flip it. So it'd be 2 over 1. So negative 2 over 1. Okay? So what happens when we multiply? So the symbol for perpendicular, you know that this is the symbol for perpendicular. When I write that? You don't? Now do you know? Okay, that's the symbol for perpendicular. Guess what the symbol for parallel is? 2 backslashes. The symbol for parallel. It's a lot nicer. The nice thing about parallel is in the word are 2 parallel lines. Right? Letter L's. Cool. Nope, maybe not. So one more thing about perpendicular lines. Sometimes it's described as the product. When you multiply, so type in your calculator 1/2 times negative 2 over 1. What does that equal? Type that in. 1/2 times negative 2 over 1. Negative 1. Okay? Do me a favor. The last question we just did, we had a slope of 2/5 and a slope, a perpendicular was negative 5 over 2. Multiply those together. Negative 1. Okay? So perpendicular slopes also have a product, always, of negative 1. If you think about it, everything's going to count, right? You're going to have negative 10 over 10. Negative 2 over 2. Because you're flipping it, it's going to be multiplied to negative 1 when you multiply by its reciprocal. Because the 5's cancel and the 2's cancel. That's really what's happening. Okay, so let's skip this part. I don't like these investigations very much. And this is just a review. Parallel lines have the same slope. Okay. Perpendicular will have a product of, their slopes will have a product of negative 1. So really, here, you can see they are negative reciprocals of each other. Opposite, right? We know one, we flip it and take the opposite side. Easiest way. So if we have a slope of 3/4, what would be the parallel slope? If it's a parallel lines, It would also be 3 over 4. It's same slope. Okay, if my slope is 3/4, what would be the slope of perpendicular to AC? Negative 4 over 3. Opposite sign, and then flipped. Easy? Not so bad? Okay, determine if the lines are parallel, perpendicular, or neither. So this guy, 1/4 and 3 over 12. Okay, 3 over 12, can you reduce that to what? 1/4. Do they have the same slope? Yep, therefore, parallel. Okay. 5 over 7, does 14 over 10 reduce? Yes. 7 over 5. So, is that parallel, perpendicular, or neither? What? Is it because you need to have one of them as negative, one of them as positive, right? They have to be opposite sign. So because these are the same sign, they're neither. They're both rising. So to be perpendicular, one has to be rising, one has to be falling in order to make that 90. If both are rising, there's no way for them to be perpendicular. You're not going to get a 90 degrees. One has to be a positive, one has to be a negative. Hot IT. Okay, because P is 0.47, Q is 6, negative 2. Find the slope of PQ. So guess what formula I'm going to use if I'm given 2 points? Slope formula, so we label them x1 and y1, x2 and y2. So label your 2 points. First point, second point. So that we can plug it in. Where can I find this formula? On your formula sheet. You do not need to memorize it. It is there. Although you might memorize it. If you write it enough times, you will. Okay, so what's y2? Negative 2, right? Here's y2, minus 7, y1, divided by x2, 6, minus 4. Okay, can you type that in your calculator if you wanted to? Yeah, let's just do that because I like to not and just simplify it, but then I want to make sure that you remember how to type it in properly. So I need to show you. Okay, what do I have to remember if I'm going to type this in? Thank you. Bracket, negative 2 minus, bracket, divided by, nope, bracket, 6 minus 4, bracket. Okay, and then math, enter, enter. We want it as a fraction. Pretty much always in this unit, we want everything as a fraction. So negative 9 over 2. Which, could we see that? Yes. Negative 2 minus 7 is negative 9. 6 minus 4, 2. Okay, we're good. Some of you are lucky because you can use alpha y equals, right? So you can use numerator over denominator, and you don't have to worry about brackets. It's really tiny. Negative 2 minus 7. If you have, like, some of the calculators, depending on your calculator, you can go alpha y equals. And then you never have to use brackets. Must you? Because you were late. Quickly. Okay. So it says, find the slope perpendicular. So we're going to write this with the symbol of perpendicular. Perpendicular to PQ. What would be the slope perpendicular to PQ? Oh, I didn't even answer the first part. Well, I kind of did, but I kind of didn't. That was slope PQ. What was it asking me to find? parallel line segment. So what would be the slope parallel to PQ? Also -9/2. Right? So we need to define the slope of PQ in order to find the parallel slope, which is the same, but I did need to answer the question. It's always good to answer the question. So perpendicular, what would you put? Close. +2/9. Why positive? Because the other one was the negative. So they're always going to be opposite signs and flipped. So if your slope given is negative, the perpendicular is positive. If your slope given is positive, your perpendicular is negative. Okay, just opposite sign and flipped. Alrighty, we're going. We're almost done. Short and sweet lesson. I think it's short and sweet.
You know how when I was lesson 6, like \1 or like M.
Right.
I was so confused, but now
Because the one didn't look like a proper one.
Yeah.
Either.
Now I get it.
Okay. Oh, good. It is. It's kind of backwards. But it's because it's from 2 different units in the workbook. Okay, good. Triangle LMN. This is a great test question. I'm going to write that. Great test question. Possibly. A question like this tends to be a great written response, and it shows up on quizzes and unit exams. Not that it will for sure. I'm not going to make promises I can't keep. Or maybe I can. So we have a triangle, LMN. Use the slopes to show that the triangle is right-angled. At L. Oh, that's nice. They tell me it's at L. So, how does that relate to what we're doing here? Okay, so right angle is a what type of angle? A 90-degree angle. And a 90-degree, if you have 2 lines meeting at a 90-degree, they must be perpendicular. And to prove if 2 lines are perpendicular, what can I find? Their slopes. If I know their slopes and the slopes are perpendicular, then it meets at a 90. Beautiful. Okay, so we need to find the slopes. Now they tell us that it's at L. So which 2 slopes do I need to find? LM, and LN. Okay, those are the 2 slopes. We want to prove that these are perpendicular to each other. Okay, so LM. Slope of LM. Y2 minus Y1. So here, who's going to be Y2? X1, Y1, X2, Y2? Sure. So second Y minus first Y. 7 minus 2 divided by second X minus first X. -2 minus, can you see that all right? Back there? Yeah? Minus what? -4. Minus a -4. -2 minus -4. So second X minus first X. 7 minus 2 is 5. When you subtract a negative, what do you want to do? Add a positive. So, put that in red. Plus, -2 plus 4. Well, it doesn't look good. +2. Okay, there's the slope of LM. Now let's do the slope of LN. So we're looking now at L and N. So Y2 minus Y1, second Y value. Which one's the second Y value? 0 minus first Y value. Second X value? 1 minus first X value? -4. 0 minus 2? -2. 1 minus -4? +5. Because you're subtracting a negative, we're adding. All right. Is it a right angle? Yes. So since the slope of LM is perpendicular to slope LN, the triangle is right angled. Okay, the toughest question is example 5. It's not that tough, but it's the toughest type you can see when you're dealing with parallel and perpendicular lines. Your last question, and you're done for the lesson. That's good. You have two lines. Two lines have slopes -3/4 and k/5 respectively. Find the value of k if the lines are parallel. So if they're parallel, what do we know about these two slopes? If they're parallel, slopes are equal. They're the same. They're equal. So I can take those two values and do what with them? -3/4, k/5. I can make them equal. I want k by itself. How do I get k by itself? Multiply both sides by 5. So 5 times -3/4. You can type that in your calculator if you want. Or, if you're multiplying fractions, 5 times, same as 5/1. How do we multiply fractions? Straight across. So it becomes -15/4. Or, what is that as a decimal? Or -3.75. Either or is good. What do we know about perpendicular slopes? Yeah? Right. So if we know one of the lines has a slope of k/5, right? What's the perpendicular to it? Okay, or if we know these two are perpendicular to each other, right? They tell us that those are perpendicular to each other. So what would it be equal to if those are perpendicular? 4/3, right? If we know that those two lines are perpendicular, to make them equal, k/5 would be equal to 4/3. Since if the first slope is -3/4, then the perpendicular is +4/3. So 4/3 and k/5. How do I get k by itself? Multiply by k, no, 5. Don't text. Which equals 20/3, or I would be repeating decimal though, right? 6.6 repeating. I don't like repeating decimals. I'd leave it as a fraction if I were you, but okay. All right, so that's it. That's this lesson. So circle the following. Okay. 1, 2. It's going to start getting a little bit more challenging soon, so you want to make sure you have this down. 3 is A, C, E, G, and I. All of 4 5, not 6. 7 and 8. 10 A and D, so not 9. A and D. And 11 A and C. And then 15. Yeah, it's crazy. Well, we have like 5 weeks of school.
Yeah, it's just the way that everything's kind of like,
Yeah.
everything's kind of pretty strict.
Yes. We only have 2 units. And we'll be halfway done this unit by the end of this week.
Is it this unit and then 2 other units?
No, this unit and then 1 more. Yeah.
The next one is smaller.
No, it's about the same length as this one. Maybe just a little bit